learners. So in this video, we will compare light waves and sound waves. So we will see similarities and differences between these two. First, we will see what are the similarities between these two. So first of all, these two are waves. Okay, these two behave wave properties. So we can express sound wave and light wave in terms of their frequency, amplitude, and wavelength. Okay. So both of them have finite speed. It means both of them will travel with finite speed in a medium. At the same time, both of them will move with different velocity in different medium. Okay. So for example, suppose take a sound wave travels in air with a particular velocity 330 meter per second. It moves with a different velocity in water. Velocity of sound in water is different. Okay. So similarly, light also in a vacuum it moves with a velocity of 3 lakh kilometer per second, whereas light moves with different velocity in glass. Okay, so velocities are different in different medium for both sound and light waves. Okay, so both waves behaves the or follows the law of reflection, refraction, and interference. Okay, whether it is sound wave or light wave, because both of them are having wave properties, so they both will follow the. In both cases, we can observe reflection, refraction, interference, diffraction, all wave properties, wave phenomena we can observe in both cases. Okay. So for example, you can say that reflection of sound is nothing but echo. Okay, reflection in the case of light is we use a mirror to see our images. Okay, so similarly, interference is observed in sound, which is known as beats. So if you vibrate to near frequency tuning force, then you hear beats. So beats is nothing but interference between two sound waves. Okay, so interference is observed in light also. You might have come across Young's double slit experiment, Newton rings, air wedge. There, all these things are observed due to interference of light. Okay, so we have seen three similarities particularly. So one is both of them are wave. Okay, both can be expressed in terms of wavelength, frequency, and amplitude. Both of them have different speed in different medium. Then both of them will follow the wave behaviors like reflection, refraction, and interference, diffraction. Okay. Now we will see the differences between these two waves. The nature of wave is different. The sound is a mechanical wave, whereas light is a electromagnetic wave. Okay, light is a transverse in nature, whereas sound is a longitudinal wave. So you know that longitudinal wave is nothing but the wave propagates. The vibration of the particles will be in the same direction of the propagation of wave. Okay, in whichever direction the wave is propagating, in the same direction the particle will be vibrating. So that is nothing but longitudinal waves. Sound waves are longitudinal waves. Okay. So another important difference is that medium is required for a sound to travel. So if a sound wave has to propagate from one place to another place, in between those two places, medium must be required. Medium is must for sound wave to travel. Whereas light is an electromagnetic wave which can travel in vacuum itself. There is no need to have any medium for propagation. Okay. So the velocity is drastically different for sound and light. Light velocity of the light in vacuum is 3 lakh kilometer per second, whereas in air velocity of the sound is simply around 340 meter per second. So it's very low. Okay. So one more main difference between these two is that sound waves which we can hear, the frequency range of sound wave is 20 hertz to 20 kilohertz. Okay, whereas the light waves which are electromagnetic in nature, the frequency of which is very huge, you can see 430 terahertz to 730 terahertz in the visible range. Okay, if you take the other ranges, it will be highly different. Okay, for a visible range, the frequency range for light wave is 430 terahertz to 730 terahertz. For sound, in the audible range, the frequency is 20 hertz to 20 kilohertz. So it is in kilohertz range, it is in other one is in terahertz range. Okay, thank you.